Hello everyone, my name is Chengpeng Li. Today I will present our work, Evolution-Aware Detection of Order-Dependent Flag Tests. We are Chengpeng and August from the University of Texas at Austin. Let's imagine, under the same code version, all tests pass in one run, but test 1 fails in another run, which means test 1 is a flaky test because it can pass or fail on the same code version. Flaky tests mislead the developers about the correctness of their codes. An order-dependent flaky test passes in one test order, called a passing order, but it fails in another test order, called a failing order. In this example, test 1 is an order-dependent flaky test because it fails when run after test 2. From prior work, order-dependent flaky tests are found among top 3 common types of flaky tests. And test order is not guaranteed in Java JUnit tests. As for why test 1 fails when run after test 2, it's because they have some shared state. Test 2 modifies the state that test 1 depends on to pass. Then we refer to the shared state to be the pollution. Test 2 is the polluter, and test 1 is the victim. There are many types of shared states, like heap memory reachable from static fields, file system, and databases. From prior work, static fields are the most common type of shared states. Thus, we focus on static fields in our work. Let's firstly talk about an example of an order-dependent flaky test. It's a simplified version. The first test calls a method unregistered parser to remove an entry from the static field map parsers. The second test will call the method create the parser to create a parser based on the entry. If there is no such an entry, it will do an exception. And they have a shared static fields named parsers. If the first test runs before the second test and removes the entry that the second test needs, then the second test will fail. Thus, we refer to the first test to be the polluter and the second test is the victim. If we look at the timeline of this order-dependent flag test, we can say the whole project started in 2010. The polluter test class was introduced 2 years later, and the victim test class was introduced 5 years later and became Flaky at this time. At this commit, both the polluter test class and the victim test class have both been introduced in the test wait. Thus, we can detect the order-dependent flag test at this commit. Ideally, we want to detect the order-dependent flag test as soon as the victim test class is firstly introduced, and we can fix them immediately. However, it was fixed 3 years later. To detect the order-dependent flag tests after the flakiness introducing commit, we can apply ID flakies. It will run all tests in random orders for the same code. If it can find both the passing orders and failing orders for one test, then we output this test as an order-dependent flag test. However, we cannot know at which commit the flakiness is first introduced. Thus, we need to run all tests after every commit. However, running all tests in random orders for the same code after every code change is very costly. Thus, we want to run fewer tests. Fortunately, there are some existing techniques can help us. Regression test selection techniques can run subset of tests by analyzing the code changes and using the dependencies between code, test, and code. It is a common way to reduce the cost of testing in general, and we assume the developers have already applied RTS after every code change. In this example, at this commit, based on the class abstract AIS message listener and the test class abstract AIS message listener test were changed, and the The test class abstract AIS message listener test depends on class abstract AIS message listener. The RTS technique will only select the test class abstract AIS message listener test. It is the victim test class. If we only select the test in the victim test class, we cannot find the failing order. Thus, we need to conduct additional analysis to include the polluter test class as well. We propose ink-ID Flakys to efficiently detect newly introduced order-dependent Flaky tests when the flakiness is firstly introduced. It will run fewer tests in different orders after every code change. It starts with the affected test provided by RTS technique that is already used, and then includes additional tests that are related to the affected tests, and they should be run together. The input for ink-ID Flakys is the whole test suite. Selected tests and dependency maps between test and code provided by RTS technique. It has two main components, analysis part and execution part. Finally, it will output the newly introduced order-dependent Flaky test at this commit. As for the analysis part, at this commit, class 1 is changed, and test 1 and test 3 depends on class 1. Based on the changes and dependency maps, the RTS technique will only select test 1 and test 3. Then we will go through the dependency maps of the selected test by RTS technique. For test 3, it depends on class 3. Class 3 does not contain static fields, which means test 4 and 5 cannot modify the state that test 3 depends on, or test 4 and test 5 do not depend on the state that test 3 may modify. As for test 1 depends on class 2. Class 2 contains static fields, which means test 0 and test 2 can modify the state that test 1 depends on, or test 0 and 2 depend on the state that test 1 may modify. As for test 6 to test 8, they depend on class 4. However, this dependency map has no relationship with the already selected tests. Finally, ink-ID Flakys will only select the tests from 0 to 3. As for the execution part, ink-ID Flakys will run fewer tests in random orders during execution. If it still can find both the passing orders and failing orders for one test, then we output this test as an order-dependent Flaky test. However, running fewer tests in random orders does not mean we can save time finally, because there are still some potential time to do analysis. The final goal is that the time to do analysis and running fewer tests in random orders is faster than the baseline ID Flakys. As for the environmental setup, we evaluate on 67 order-dependent Flaky tests with known flakiness introducing commits from a public dataset, IDOF. We use concrete regression test selection tools, Ecstasy and STARS for ink-ID Flakys. Ecstasy is a dynamic regression test selection tool. STARS is a static regression test selection tool. Ink-ID Flakys E is the ink-ID Flakys which builds upon Ecstasy. Ink-ID Flakys S is the ink-ID Flakys which builds upon STARS. We will run an ink-ID Flakys with 10 test orders, which is recommended by the baseline ID Flakys to detect newly introduced order-dependent Flaky tests. We will also run ink-ID Flakys across multiple commits and compare against running ID Flakys with the same number of test orders. As for the research questions, we have two RQ. RQ1, how much faster is ink-ID Flakys than the baseline ID Flakys? RQ2, can ink-ID Flakys detect the newly introduced order-dependent Flaky tests as the flakiness introducing commits? Due to randomness, we may not detect the order-dependent Flaky tests in a limited number of test orders. Thus, we evaluate the effectiveness of the technique to be the potential to detect order-dependent Flaky tests. Firstly, we found all the polluters for all the victims as the flakiness introducing commit. If we only select the victim, we cannot find the failing order. If we only select some of the polluters, we cannot find the passing order. Thus, we need to select the victim and at least one of the polluter to expose both the passing order and the failing order. Then we say ink-ID Flakys has the potential to detect this order-dependent Flaky test. R21. How much faster is ink-ID Flakys than the baseline ID Flakys? We can say the baseline ID Flakys selects about 300 tests. Ink-ID Flakys E selects about 65% of tests. Ink-ID Flakys S selects about 70% of tests. The baseline ID Flakys takes about 76 seconds. Ink-ID Flakys E takes about 68% of time. Ink-ID Flakys S takes about 70% of time. And we can say Ink-ID Flakys indeed have time savings over the baseline ID Flakys. RQ2. Can ink-ID Flakys detect the newly introduced order-dependent Flaky tests as the flakiness introducing commits? We refer P to be the potential to detect the order-dependent Flaky test, D to be detecting the order-dependent Flaky test within 10 test orders. Both the ink-ID Flakys E and S have the potential to detect 100% order-dependent Flaky tests. However, if we only use the tests selected by RTS technique, ecstasy and stars, it is not enough. These techniques can only help us to have the potential to detect 70% of order-dependent Flaky tests. As for why ink-ID Flakys cannot detect the order-dependent Flaky test within 10 test orders, you can see more details in our paper. To conclude my presentation, we propose ink-ID Flakys to detect newly introduced order-dependent Flaky tests. It leverages RTS techniques and additional analysis to include necessary tests to run for detecting the Flaky tests. It provides a reduction in both tests selected and time to run, while having the potential to detect the newly introduced order-dependent Flaky tests. We plan to prioritize the test orders to detect newly introduced order-dependent Flaky tests faster. We also integrate ink-ID Flakys as a new plugin into the main code of ID Flakys. You can check our code at this link. Feel free to email me if you have any questions. Thank you very much.